let's look at this question. Square ABCD is inscribed inside a circle. Another square is inscribed between square ABCD and the circle such that its two vertices are on the circle and one side lies along AB as shown in the figure. The ratio of the length of the sides of the smaller square and the bigger square is. Okay. I'm taking the side of the bigger square as 2a just to get a radius in normal terms. So the diagonal could be root 2a. So this is the center of the square. And this length here is 2a. Fine. Now what I'm choosing to do here is choosing to take this length will be how much? Root 2a. From which when we drop this, if the side of this square is b, let us take this length will be half of that. So this will be b. This is a. Sorry, this is a. This is 2b. Let me join the top of this square to the center. Okay. So now I have a right angle triangle with one side is a plus 2b, one side is b, and one side is root 2a. So I can link them up. A square plus 4b square plus 4ab plus b square is equal to 2a square. Okay. So now how do I break this up or do this nicely? 2a square. Finally, what do I need? The ratio of length of sides of this square. I need a by b finally. Okay. 2a square here. I just have a square minus b square is equal to 4b square plus 4ab. Okay. I can get this as a minus b into a plus b is equal to, if I take 4b common, I get b plus a. I know b plus a will necessarily be a positive value, so I can cancel this and I can cancel this. Wonderful. Or a is equal to 5b, or a by b is equal to 5 by 1. The final ratio that they asked was sides of smaller square to bigger square. I've got bigger to smaller, so the answer to this question is option A, 1 by 5.